I came to Caltech in 1966 on the faculty, working in relativity. I began thinking in great detail about the future of gravitational wave physics and astronomy. Ray Weiss had been the primary inventor of the laser interferometer gravity wave detector. And his classic paper, written in the early 1970s, just lays it out and says, here's what you have to deal with, here's how you deal with it.
The important thing to do in this field was to do experiments to test the theory. And those are hard experiments because it turns out gravity, relative to all the other forces we know about, is a pipsqueak, it's a nothing.
Between 1980 and 1983, NSF funded Caltech to build a 40-meter prototype. And NSF funded MIT to do a feasibility study. So each of these efforts then, running in parallel, became crucial inputs.
In 1989, we made the proposal to build LIGO. That was a Caltech-MIT joint proposal.
And in 1992, NSF, after very careful review, said, okay, we're going to go forward with this, we're going to fund the project. And this was a bold thing. I mean, NSF took a bold step.
NSF bought in because they had faith in Barry Barish, the most brilliant director of large projects that physics has ever seen.
He immediately saw that some of the things that needed to happen should be happening quickly, like you need to build buildings, you need to build the observatories. And it took years. Hanford got started first, then Livingston. And then, of course, once the facility's constructed, then you have to start putting in the detectors. In 1999, there was a dedication ceremony. The interferometers were working. They weren't working at anywhere near their design sensitivity. There was a lot of work that needed to be done before we were ready to go into the first observing run. Nobody had ever made something like this before, so there was a lot of technological challenges that needed to be overcome. Barry Barish realized that if you're building these big interferometers, you better have a community.
The LIGO scientific collaboration is about 1,000 people. We all want to detect gravitational waves. We all want to start doing gravitational wave astronomy.
We don't have two collaborations saying who detects it first, who detects it better. We work together.
We ran our initial detectors from 2002 to 2010.
We saw nothing. Now, you say, well, that's a terrible defeat. That's not true. The LIGO scientific collaboration was in existence, and they were deeply involved with the data analysis and tracked down everything that we didn't understand about that detector and found out what it was. We had already proposed that in the 1989 proposal, that we were going to do a two-stage thing. We would build the initial detector, and then we would build a follow-on detector with the experience we'd gotten from the initial detector called Advanced LIGO.
We rebuilt our detectors. We've been redesigning them for about 12 years.
So we have more light, better suspensions, and better isolation from the ground, and it's that combination that allowed LIGO to become 10 times more sensitive.
It was Monday morning, September 14th.
I knew that there was something going on because I subscribed to the logs.
This particular log pointed to something that looked like it might actually be a gravitational wave.
What I saw is what's called a time frequency plot, called a chirp. And it was strong. It was unbelievably stronger than anything I expected to be a first detection. It was so strong you could see it by eye. And here was the chirp at Hanford, Washington, and there was the chirp at Livingston, Louisiana. And I thought, my God, this looks like it's it.
It was just perfect. In fact, it was almost too good to be true. When I looked at it, I said, well, somebody must have done something wrong and injected a signal.
Nobody right away believed it. Everybody thought it was a fluke. It was too good. And it took us a while to get to the point where all of us believe it.
It's monumental. It's like Galileo using the telescope for the first time.
When our descendants look back and they ask, what is the legacy of that era for humanity? I think it will be rather similar to us looking back on the era of the Renaissance when we say, well, the legacy was great art, great music. And so I think LIGO and gravitational waves, along with the electromagnetic study of the universe, will be a huge part of our legacy for future generations.